All right, so 9-3 is the last section before your quiz. Yesterday we looked at arithmetic sequences. Today, shocking, we're going to look at geometric sequences. So, the difference between arithmetic and geometric, remember arithmetic was adding or subtracting by a common difference, right? Whereas geometric is multiplying or technically dividing. I mean, really, we consider, if you want to call it the common difference, it's really not called that. It's called a common ratio. Technically, they want to look at it as if it's always multiplication. So what if I'm dividing by 2? What would be the common ratio? 1/2. So you do need to realize that, right? And that's how you'll show division, is it'll be a fraction. Okay? So we have a sequence here, 3, 9, 27, and 81. To go from 3 to 9, would you multiply by 3 or divide by 3? 3 times 3, I'd have to multiply, wouldn't I? So my common ratio would be just 3. So R would be 3. A sub 1 would be 3. Okay? And it doesn't matter, I don't have to, all I have to give you is 2 consecutive terms in the sequence. You can always find that common ratio. But if I give you the second term and the fourth term, it won't be so easy to find. I'll show you how you have to find that on the back. All right, so let's look at example 1. We're going to find the terms of a geometric sequence. So we'll just write out, I don't know, we'll do 4 more. So we already know that a sub 1 is 3. So let's do a sub 2. Won't I take 3 and multiply it by the common ratio of 2 to get it? Right? And so a sub 2 should be 6. Then a sub 3, I'll take the 6 and I'll multiply it by the common ratio of 2. And I get 12. So find 4 and 5. It's almost like a recursive, isn't it? Almost. I guess technically you could write it as recursive. So your sequence would be written out as 3, 6, 12, 24, 48, dot, dot, dot. So that's easy. I bet you wish all your problems were that way, right? Mm-hmm. Not so. Okay, so then let's look at what the nth term of a geometric sequence looks like. Again, I would put this on a flashcard, learn it, learn the parts of it. The first thing I would do when I take a test would be to write all these down to get it out of my head, right? There we go. So we will always take a sub 1 and multiply it by the common ratio raised to the n minus 1. So n is the position of that term in the sequence. So if I'm finding the 4th term, I'll still take the 1st term, but I'll multiply it by the common ratio raised to the 4 minus 1, so raised to the 3rd. Because if you think about it, look at the sequence up here. 1, 2, 3, 4 terms, right? So 24 is the 4th term. How many times did I multiply 2 to get to 24? I took the first one here, right? And I multiplied it by 2, 1, 2, 3 times, didn't I? To get to that 24. Do you see why they're doing n minus 1? And then I can always, so long as I know the first term, I can always find any other term. All right, so then let's look at example 2. We have to actually find the formula for the nth term. So in that formula, I need to know a sub 1 and I need to know r. If I know those two, I'm good to go. So what's a sub 1? 6. Yeah, 6. So that's easy, right? It's just an identify thing. How do you find r? What's one way I could find r? Yeah, and you have to know which way to go, right? So always go to the right over the left. So right over the left, so you might want to say right over left, the right term over the left term. And so you could do 24 over 12, 48 over 24, 12 over 6. I, of course, would choose the smaller number possible. So 12, and could I do 24 over 6? Could I do non-consecutive numbers? No. So 12 over 6 is 2, right? And then just double check it. 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. So yes, that works. So then apply your formula. So we're going to use a sub n is equal to a sub 1 times r to the n minus 1. We're going to leave n's in there because we're finding the formula for the nth term. So I will leave a sub n exactly as it is, but I'm going to replace a sub 1 with 6. I'm going to leave the r in here as is. I'm sorry, I've just lied. Times, and I'm going to use parentheses. We know our r is 2, don't we? To the n minus 1. Why would I use parentheses? Yeah, I want to make sure that the reader of this formula understands that it's just the 2 that is being raised to the n minus 1, not the 6. Right? So my final answer would look like a sub n is equal to 6, parentheses 2 to the n minus 1. Could your common ratio ever be negative? It could. Sure it could. And what would happen is if you have a common ratio that's negative, you'll have interchanging of plus minus, plus minus, plus minus. Right? Because sometimes you'll multiply it by a negative, sometimes by a positive, so it'll switch up. So then if I wanted to find the 50th term, what would I do? 50 minus 1 is 49, so I'd have to actually raise 2 to the 49th first, and then multiply it by 6. And hopefully I'd have a calculator, right? That would be really mean if I made you do that by hand. So this one is asking just that, only it's asking for the 12th term. And you will want your handy-dandy calculator. So here I've given you a sub 1 and r. Do we have to do anything to find what we need to write the formula for the nth term? No. But you do have to find the formula, so you have to write that first. So again, we're going to start off first, as I'm throwing pens at myself. We're going to start off with a sub n is equal to a sub 1 times r to the n minus 1. Replace what you know. So a sub n is equal to a sub 1 is 5. I'm going to use parentheses. My r is 3 to the n minus 1. So there's my general formula. I didn't have to do any math for it. I just had to know the formula and plug it in. So then I'm going to find the 12th term. So n becomes 12. So a sub 12 equals 5 parentheses 3 to the 12 minus 1. So if you're using your graphing calculator, I'm going to pull away from here for a minute. Use your parentheses, right? So you don't have to do these separately. So if you're using your graphing calculator, 5 parentheses, 3, n parentheses, use your caret button. What are you going to raise it to? I mean, I would think you could do that, right? At least that much. So raise it to the 11th. See why you're glad you're using a calculator. So we get a large number, 885,000, so a sub 12, 735. That was part of it. They didn't ask us for the general formula, but if they had, and that could be part of the question, find the, a sub n, and then find a sub 12. So those aren't very taxing, are they? Okay. So then we're going to use some strategies that we used yesterday with the arithmetic sequences on the back. So look to the back. So we're going to find a term of a geometric sequence. So we have to find the third term. But they've given us a sub 1, and they've given us a sub 4. Right? We don't know r. We don't have two consecutive terms in order to find r. We do know a sub 1. But the problem is we don't find r. Do you remember what we did with the arithmetic sequence yesterday? When they did this? Because remember I gave you like a sub, I don't know, 4 and a sub 13. Remember that? We did do 13 minus 9, right? But it's somewhat similar. Can't I take, look at your original formula. A sub n is equal to a sub 1 times r to the n minus 1. What if I did, I know a sub 4 and a sub 1. What if I put a sub 4 here and a sub 1 here? So if I did a sub 4 equals a sub 1 times r to the, isn't n 4? 4 minus 1. Replace what you know. We know that a sub 4 is 54 equals, I know that a sub 1 is 2 times r to the 3, right? What do you propose we do now? That's a lot better, isn't it? Use your algebra, what do you do? Yeah, so this would be, I would call this step 1, right? And then let's do step 2 over here. Let's take 54 equals 2 times r cubed, and let's divide it by 2. A very happy thing occurs. I'm going to put r cubed on the left equals 27, right? How do you find r? What's wrong, Zach? That flapping noise? Yeah, that's my new air conditioner noise. Along with the loud air conditioner, now I have the flappy noise going over there.
It's like something's banging on the wall. It's like almost like a feet.
Is there a squirrel in the wall? It's not that kind of feet, is it? Because there's squirrels that go up that wall. I can't hear anything with this on. I'll come over there in a minute. Okay. So how do I find r?
Cube root.
Cube root. So I'm going to take the cube root of this side, right? And the cube root of this side. So the cube root of r cubed is r. What number times itself gives you 27 3 times? 3, right? So now I know r, and now I know a to the first, or a sub 1, right? So step 3, I can write my a sub n formula. So a sub n is equal to my a sub 1 is 2. I'm going to use parentheses. My r is 3 to the n minus 1. So we created our formula after we found r. We are right so far. Now to find the third term, put in 3 for n. So a sub 3. I mean, I guess technically you could take 54 and divide it by 3, couldn't you? That should get you the right answer also, but we'll do it algebra. So we get 2 to the 3 squared. So is this 36 or is it 18? Yeah, because you're going to square the 3 first, right? And so it equals 18. So a sub 3 is 18. And how can you check that? Well, we could take 54 and divide it by 3. Do we get 18? Yeah. Or you could take a sub 1, which is 2, equal to what's 2 times 3? 6 is the second term. What's 6 times 3? 18 is the third term. So, I mean, technically you could have done it any of those 3 ways, right? We're higher level thinkers. We're going to use our algebra. All right, so then the last 2 questions, we're going to find the sum of a finite geometric sequence. Finite means that it ends. It's not infinite. So again, if I were you, this would go on a flashcard because you got 3 formulas for this section total. And it gets a little confusing, doesn't it? We're going to take, to find the sum of any geometric series, we're going to take a sub 1 and multiply it by this fraction. 1 minus r to the n divided by 1 minus r. So let's see how that works. So if I'm finding the sum of a finite geometric series, I mean, I guess technically I could find all 9 of these terms, because who asked me that yesterday? Was that you that asked me that yesterday? Couldn't I just find the terms and add them up? I mean, if there were 4 terms, honestly, I probably would find the 4 terms and add them up. But 9 is kind of in that realm of, you know, that's almost as much work as running it through the formula. If I gave, you know, if this went from 1 to 50, are you going to want to find 50 terms and add them together? And you could, and some of you would. I've seen you do that on tests. But it's not the way you're supposed to, right? So let's go ahead and write the formula just to let you know how this is working. So we've got our sigma notation, right? This is telling you that n, so we go from term 1 to term 9. This number right here is going to end up being your a sub 1 nearly every time, depending upon how I write it. But usually if it's written, it'll be written something looking like this. This is usually going to be your a sub 1, and this is usually going to be your r. So r here looks negative, and I'll show you why that is. So we're going to run through and find a couple of the terms. So we're going to find the first term. So a sub 1 is equal to 1 times negative 2 to the 1 minus 1. Isn't that 1 times negative 2 to the 0? What's anything to the 0 power? 1. So 1, do you see why this coefficient will end up being a sub 1? Because if this is n minus 1, you're always going to have 0 up here, right? So technically, you can kind of do a shortcut, and you can realize that, oh, that is a sub 1. So we end up with 1. If I find a sub 2, so I've got 1 times negative 2 to the 2 minus 1.
Why does the calculator make it negative?
Say that again?
Why does the calculator make it negatives? You're raising the negative to the power.
So your calculator made it negative.
Yeah.
Did you use parentheses? That's why.
No,
Because if you don't use parentheses, your calculator does not think the negative is raised to the exponent.
No, mine's in the
Which one did you do?
What happens when you want to square negative numbers? It says it's negative.
The first one? Are you talking about a sub 1?
No, I just did number
A sub 2. Okay, so let's just do it on the calculator. Okay, so I'm going to pull this out a little bit. So you need to put, I'm going to put 1 there. We don't really need to, but I'm going to put 1 there. Parentheses, negative 2, end parentheses. Raise it to the, what's 2 minus 1? 1. What'd you get? Well, because what's negative 2 to the first? Negative 2 times 1. Negative 2. Remember how I said that r could be negative? And if r is negative, won't you have alternating plus minus signs? So yes, it does make it negative 2, and that is exactly what we have. Because we have 1 times negative 2 to the first, which is negative 2. So far that sum is negative 1, isn't it? The next one should come out to be positive. So a sub 3, 1 times negative 2 to the 3 minus 1, which is 1 times negative 2 squared. What's negative 2 squared? 4 times 1 is 4. So it did come out positive. Run it through your calculator if you don't believe me. 1 parentheses negative 2 raised to the second power. Then we get positive 4. So are we okay and clear on all that? Okay. So, I mean, I could do this forever and ever, right? Up to, well, I could do this up to the 9th term, couldn't I? But who wants to do that? So let's go ahead and run it through the formula up here. So we're going to run it through that formula there. So do I know a sub 1? I do now. Isn't this a sub 1? And do I know r, my ratio? This, and you might want to write yourself a note, this is usually r, and this is usually a sub 1. I say usually. Because if n is not equal to 1, well, if we get into that, we'll talk about it. I'm not going to muddle your brain with it yet. But assume that that's correct. So let's go ahead and run through the sum of how many terms. What's n? Because 9 is our higher bound, right? So the sum of 9 terms is equal to a sub 1, we found to be 1, times 1 minus r is a negative 2. So be careful with your negatives. So r is a negative 2. We're raising it to n, which is 9. So the whole negative 2 gets raised to the 9th power. So you have to raise that to the 9th before you can subtract it from 1. Divided by 1 minus that negative 2 again, and parentheses. So we get equals. Do I really need the 1 in there anymore? No. So I'm going to drop the 1 in this case. 1 minus, then take your calculator and do negative 2. Make sure that you use parentheses. If you don't use parentheses, you're going to get the sign wrong. So negative 2 raised to the 9th power. Negative 512, right? And if I have odd negatives, it should be negative. So I have negative 512 over, what's 1 minus a negative 2? 3, because it's 1 plus 2, right? So this is 3. And doesn't this become a plus plus? So don't we end up with 513 over 3? Right? Weird but true. Maybe he's stuck in the wall. All right, last one, and then I'll come over and listen to your preacher in the wall. Yeah. Oh, it does go into, sorry, 513, because they distracted me with the preacher in the wall, is divisible. Is divisible by 3. And how do you know that? What's 5 plus 1 plus 3? 9. Okay. So divided by 3, 171. So our final answer is 171, which makes sense. And it's positive 171, right? All right, last one. Of course, then we have to find the sum of an infinite geometric series, of course, one that never ends. So the previous one or this one? The sum of an infinite geometric series is much simpler than the finite geometric series. Notice here, you're just taking a sub 1 and dividing it by 1 minus the common ratio. And don't they look somewhat similar? Right? All right, so we could find a couple of these if you wanted to, but why bother? Let's run it through the formula. I think you get the idea. So step 1, I need to know a sub 1 and r. So looking at this, knowing what I just told you before, what's a sub 1? 4. So this is going to be your a sub 1. If you don't believe me, our first term is 1. What's 1 minus 1? 0. What's anything to the 0 power? 1 times 4. So that has to be a sub 1. Then what's r? So that's our r, right? So let's find the sum. And notice that I don't have any sub here because we don't know how many terms are in that sequence. So sum is a sub 1 is 4 divided by 1 minus, and my r this time is positive 0.6. So I end up with 4 over, what's 1 minus 6 tenths? 4 tenths. And then without a calculator, wouldn't I move the decimal one place to the right? And which is multiplying it by 10. Wouldn't I multiply that by 10? So I really have 40 over 4, which is what? 10. So what happens as I keep raising this n to a higher and higher number, then this starts getting smaller and smaller and smaller. And it eventually will add up to 10. It's not going to go over it, but you'll see a sum that approaches 10. All right, so now be quiet. I'm going to go listen to your little critter.